Hello friends, welcome back to the CSC game. Today we are going to explore first order logic, a powerful tool in artificial intelligence and knowledge representation. We will cover its syntax and semantics, how to use first order logic and the role of knowledge engineering in this context. So let's dive right in. First, let's define what first order logic or FOL is. First order logic extends propositional logic by allowing us to express statements about objects and their relationships, while propositional logic deals with whole statements that are either true or false. FOL introduces quantifiers and predicates, enabling us to make more complex assertions. For example, in FOL, we can express statements like all humans are mortal or there exists a cat that is black. This ability to quantify over objects make FOL much more expressive and suitable for representing knowledge in AI. Now let's talk about the syntax of first order logic. The syntax consists of several components. Constants. This refers to specific objects in the domain. For example, Socrates is a constant that refers to a specific individual. Second is variables. These are placeholders for objects. For instance, X can represent any object in the domain. Third is predicates. This expresses properties of relationships among objects. For example, human Socrates indicates that Socrates is a human. Functions. This map objects to other objects. For example, mother of X could return the mother of the object X. Fifth is quantifiers. There are two main types. A universal quantifier indicates that a statement applies to all objects. For example, for all X human of X to mortal of X, means for all X, if X is a human, then X is mortal. Existential quantifier indicates that there exists at least one object for which the statement is true. For example, there exists an X such that X is a cat. These components come together to form well-structured sentences in first order logic. Semantics. Next, let's discuss the semantics of first order logic. Semantics refer to the meaning behind the syntactic structures we create. In FOL, the semantics is based on interpretations, and interpretation consists of a domain of discourse and a mapping of constants, predicates, and functions to elements in that domain. For example, if our domain is all living beings, we can interpret the constant Socrates as a specific human in that domain. The predicate human of X would be true for all humans in our interpretation. The truth of a FOL statement is determined by whether it holds true under a given interpretation. For instance, the statement for all X human of X to mortal of X is true if every human in our domain is indeed mortal. Now let's look at how we can use first order logic in practice. FOL is widely used in various fields, including artificial intelligence, databases, and knowledge representation. For example, in AI, we can use FOL to represent knowledge about the world and reason about it. We can encode facts, rules, and relationships, allowing an AI system to infer new knowledge. Let's consider an example. We can represent the facts for all X, human of X to mortal of X, all humans are mortal. Human of Socrates is a human. From these facts, we can use reasoning to conclude mortal of Socrates is mortal. This ability is to derive new information from existing knowledge is what makes FOL so powerful. Finally, let's touch on knowledge engineering in first order logic. Knowledge engineering is the process of designing and building systems that can represent and reason about knowledge. In the context of FOL, this involves creating a knowledge base that encodes facts and rules about a specific domain. For instance, in a medical diagnosis, we might represent knowledge about diseases, symptoms, and treatments using FOL. This allows the system to reason about patient symptoms and infer possible diagnosis. The challenge in knowledge engineering is ensuring that the knowledge base is complete and consistent, as well as making it efficient for reasoning a task. By leveraging first order logic, we can create robust systems that can handle complex reasoning and provide valuable insights based on the encoded knowledge. And that concludes our exploration of first order logic, its syntax and semantics, how to use it, and the role of knowledge engineering. I hope you found this overview helpful, and that it inspires you to delve deeper into the world of logic and artificial intelligence. If you enjoyed this video, please give it a thumbs up, subscribe to CSE Guy, and comment it. Thanks for watching, and I will see you in the next video.